Hi everybody, welcome to the first section in calculus for business math and social science. Section 9.1, Introduction to Limits. Before we go to the definition of limits, let's just look at some simple example with the graphical approach. So, first, the graph of the function y equal to f of x. So when y equal to f of x, the graph of that is the set of all order pairs x and the y values is equal to f of x. So when we want to graph y equal to x minus 1, for example, the easiest way, just plot a bunch of points. So let's choose 0, 1, and then 2, right? So we're going to put 0 into x, 0 minus 1, and we're going to put 1 into x, put 2 into x. This is equation, the function of a line, so it is going to be a line, and for a line we only need 2 points. Here we have 3. So when x equal to 0, y equal to -1. When x equal to 1, y equal to 1. And when x equal to 2, y equal to 3. Then we have a straight line. And that line is the graph of the function y equal to 2x minus 1. Right? Simple enough. Next, given the graph of y equal to x squared plus 1, complete the following table. So we're going to just put the x values into the function and find the y values. So that's simple enough, right? I'm just want to use the calculator. Or I should say I just want to demonstrate how to do this with the calculator. It's easy, just put in the number. We can do this by hand, of course. Right. On the calculator, if it is a graphing calculator like this, we enter y equal to, and we enter the function. We can enter x squared plus 1, or we can say x times x plus 1. Either case, we have the function. When we're done, just hit y equal to, when we hit y equal to, enter the function. When we are done, second mode, right? Y equal to, enter the function, second mode to quick. Right, so we have a function. Now how do we evaluate? Well, there are a lot of ways to do that. We can go to the table, give us the values of x, that's the values for y, right? Just second table. The only problem is we don't see 0.9 here, do we? Right, so we have to try something else. If we want to evaluate the values of the function, there's 2 ways to do that. One is hit second and trace, go to calculate the values of the function. So the first option there, hit enter, right? Graph the function and then ask you what do you want for x, right? And then you say when x equal to 0, so I hit 0 and enter. We have 1, right? Now for 0.9, just put 0.9 and y equal to 1.81. We don't have to go second trace every single time. We just hit the new number for x and just hit enter, like 0.99 and enter. And hit the new number. Okay, of course you can continue to do this. So that is one way to do it, second trace. The only problem with this is if we enter the number outside the windows, it will not do it. So we can only enter the numbers within this, which is in this standard windows from -10 to 10. Right. So the second trace calculator values only do whatever the x values fit in the window. If it is outside the window, we have to get the values. So it's variable, y variable, function y1, and then we can say when x equal to 1, evaluate at 1, it equal to 2. Right. Again, variable, y variable, function, and then y1. Or if you hit alpha and trace and you see the bottom menu pop up like this, just going to say y1, and then we just say make sure there's a parentheses. We evaluate at 1.01. Make sure there is a parentheses there. And then 1.1 alpha trace y1 1.1. Or if you don't want to do that, just hit second and then enter. It just pull up the last entry and we say let's change this to 2. Right, so that we complete the table. Now just want you to focus on this. Let's assume that we do not have these values. When x goes to 1, the y values, the function goes to 2, right? So whether we have this or not is not really important. So we say as x get closer and closer to 1, the values of the function get closer and closer to 2. And that is the idea of the limit. The limit of the function is where the function the y values are approaching to that values, where x approaching to some values. So the limit of the function is equal to L when x go to c. That's how we say it. That means the values of the function get close to L where x get close to c. So notice that the graph here have two values, two components, x and y. We always know what x approaching to. What we going to find out is the limit, which is what the y values are approaching to, right? And the key here is when x getting close, but will not be equal to. As close as we want to, as close as we need, but it's not going to be there. That's the idea of the limit, right? So it's getting close, but not equal to. Of course, we can also write like this. So once again, the limit is whatever f of x or whatever the y values are approaching to when x approaching to the number. Right. So let's look at this graph. Find the following limits of the graph. Well, the graph is given here. For the limit when x go to -2, -2 is here on the x-axis, right? Now, when we talk about the limit, and have two components, the x approaching to, then we try to see what is y approaching to. So when x go to this point, which is we have the vertical line here. So when x go to -2, along the function, if we go to that imaginary vertical plane or line, if you will, the y values of the function, the y values of the function approaching to this point, which is equal to 1, and on this side it is also equal to 1. So the limit is equal to 1. And then you say, what is that dot? By the way, the dot here means whenever x equal to -2, the function equal to 3. So when x equal to -2, y equal to 3. And it has nothing to do with the limit. as you see. The limit is where x gets close to something and the y values approaching to that limit. Right. The next one, when x approaching to this point, when x approaching to -1, on the left side and on the right side is approaching to this point. So the limit, the y values approaching to this point, which is equal to 2. So as you see, the difference of this problem and this problem is that the function is defined here, the function is undefined when x equal to -1. That's what an empty circle means. That means there's no point there, or the function is undefined there. So whether it is defined or not, it doesn't matter. The limit is where it gets close to. Doesn't matter what happened there. If we can get close to it, and we say how close, once again, as close as we want to, as close as we need to. So it doesn't matter how close it is, it can always get closer. That's the idea. But it's not there. Right. Limit when x go to 1. When x go to 1, it will go to this point. So what is this point? Well, it looks like 1.5, right? The reason is the ratio of x and y here. If we go 2 units to the right, we go 3 units up. So it's always 1.5 more than what the x values is. So we can say this will be 1.5. Right. Next one we have, wait, one more. Limit of the function when x go to 2. So when x go to 2, notice that this is 2. When it go from this side, it go to that point, and when it go to 2 from this side, it go to this point, which is 1. So this point do not agree. So in that case, we say number 4. We say it does not exist. I just want to spell it out for the first problem. By the way, those are Roman numeral numbers, Roman numerals in lowercase. Right. So the left side and the right side do not agree. When it gets to 2, so we say the limit does not exist. Right. Next. Definition of the absolute values of the function. An absolute values function is a function defined as the distance of that number to 0. So let's look at the distance. Let's say we have a number line, and let's say 2. What is absolute values of 2? Well, we say from 0 to 2, the distance is 2 units, so that is going to be equal to 2. And let's look at another number, -1. What is absolute values of -1? The distance from -1 to 0 is 1 unit. So it's going to be 1. As you see here, distance cannot be negative, so that's why absolute values is greater than or equal to 0. So properly, we can define absolute values as a piecewise function. Absolute value of x is equal to, this is not the negative values, this negative sign meaning opposite. So if x is less than 0, if x is negative, it's going to be opposite to it. Opposite of -1 is 1. If it is positive, then absolute value is going to be itself. So greater than or equal to 0 is going to be itself. If it's less than 0, it's opposite to that, which is also a positive number. Right. We did have one example that the left and the right do not agree, so the limit does not exist in that case. Now we define the limit properly for one-sided limit. So the notation is just a superscript negative, meaning from the left or left-handed limit, and positive, meaning from the right or right-hand limit. Right. Again, the superscript minus and plus denote the left and the right limit. So from the left, and that is the left hand limit, and from the right, and that is the right hand limit. So this is L, K. Right. Let's see how it works in this example. Find the following limit for the graph of the function. This is the graph of the function. Right. So when x equal to 2, negative, meaning from the left side of 2. Now what happened on the left side of 2? Right, left side of 2. Along the graph, when we're approaching to that point, when we're approaching, we go along the graph when we're approaching to the left side of 2. We're approaching to that point, which is 2. And on the right side of 2, we're approaching to that point. Right? So on the right side of 2, rolling along the function, going to that right side of 2, the y value is equal to 3. So that's what we have. So the superscript plus, meaning going from the right, and this are not the same. They do not agree. So the limit when x equal to 2 does not exist. Right. Next, what is the limit of the function when x equal to 4 from the left side? So on the left side of 4, it goes to that point, which is equal to 3, and on the right side of 4, it goes to that point, which is also 3. And when the left side and the right hand side agree, the limit when x go to that number is equal to the common limit. Right? So you have left-handed limit and right-handed limit. Right. Next, we're going to find the limit for the function. So up to this point, we only find limit for the graph of the function. So how do we do that? Well, let's just go over the few properties before we actually go to finding the limit of the function correctly. Right. Let's say the limit of f of x when x go to c is equal to L of g of x when x go to c is equal to m. So first, if there's just a constant, there's nothing to find. That will be the limit. Next, we have x. If we can just substitute into the function and it is defined, then that will be the limit. Well, we have to be careful with that. Sometimes the function is defined, but the limit is something else. But for most of the function, when we find the limit, just put in a number. If it is defined, that will be the limit. Right. Here, we have the limit of the sum, which could be a plus, or it could be minus. it doesn't matter. The sum of the limit is, the limit of the sum is the sum of the limits. The limit of a difference is a difference of the limits. Same thing for multiply and divide. Except when we divide, we cannot divide by 0. If there's a constant, we can take that constant outside of the limit. So those are the rules of limit. And of course, the end root, same thing. The limit of a root is the root of the limit. Just be mindful that when we have an even root and whatever inside have to be greater than or equal to 0, because square root of a negative number is undefined, or even root of any negative number is undefined. Right. We talk about more of that on section 9.3. Let's just go to some example. Right. Find the limit of this function. Well, first thing, by the way, whatever all the rules here works for one-sided limit as well. So it might have the plus superscript or minus superscript. The rules of this rule are still the same. Right, now we'll learn this in section 9.3, but when we're trying to find limit, just put in the numbers, see what happens. If it is defined, that will be the limit of the function. Right, so for most of the example, we see that the only some case that we have to consider one-sided limit. Right, now when x equal to 2, I'm just going to put 2 in and see what happens. I do not write equal sign yet, because that could be something weird here. We don't know yet, but it's not. 2 squares, 4 times 5, 20, minus 1 is 19. It is a defined number, so we're going to make it equal to. So that's that, right? So put in the number, see what happens. If it is defined, that will be the limit. For most of the problem, we can do that, except when we have piecewise function. Right, now we have the limit from the left here of 2, on the right side of 2, and on both sides. So draw a number line here, and here's 2. Right, now limit when x goes to 2 from the left. If it is on the left, it's going to be less than 2, right? So if it is less than 2, here is less than 2, we're going to use this function. It's greater, less than or equal to 2, but it doesn't matter with the equal or not. We only focus on when it's less than 2 in this case, because the definition of limit, it says it's getting close but not there. Right, so we say the limit as x equal to 2 from the left side. For this particular function, if it's less than 2, it is going to be 2x minus 1. Right, now we have the superscript. Right, the superscript is, it's just the notation to indicate that it is from the left or from the right. When we evaluate it, just put the numbers without the superscript. So 4 minus 1, 3. And this is a defined number, so we make it equal to. Right, now on this side, when x equal to 2, this is on the right hand side, it is greater than. And if it's greater than, the function is equal to x squared. So when it is with a plus superscript or from the right hand side. It's going to be this function. And once again, we substitute in the number without the superscript. It's going to be 4. So we make the limit equal to, because it's defined. Now the left-handed limit and the right-handed limit do not agree, so not the same or not equal. We say that limit when x go to 2 for the function does not the limit does not exist. Right. Now we have 3 sub-problem here. So let's look at this when x go to 0. Let's first put in numbers first. If we substitute in the number, well, divide by 0 is undefined. Actually, in this case, it's something else other than undefined. But whatever we do, we're not going to say it's equal to, right? So I try something else. Now, so get back to the case here. We have the number line of 0, right? Now, this is from the right hand side. I'm sorry, superscript minus, meaning from the left. So if it is from the left of 0, that means less than 0. Now, we did have the definition of the absolute values. If it is less than 0, it's going to be opposite. So because x less than 0, absolute values of x is going to be equal to opposite to x. When x less than 0, absolute value of x is equal to opposite of x, and then x and x cancel out. We just have limit of x go to 0 from the left side of -1, and that is -1. Right. Let's go to the next part of the problem. Now when x go to 0 from the right hand side, when x go to 0 from the right hand side, on this side, it's going to be greater than 0. So it is greater than 0, and absolute values of something greater than 0 it itself. Absolute value of x is equal to x if x greater than or equal to 0. So it's greater than 0, so it equal to itself. X and x cancel out. So that equal to 0. Right, so limit up. Sorry. Yeah, there's nothing to substitute in. So that equal to 1. Right, so limit from the left and limit on the right do not agree. So we say the limit when x go to 0 over x does not exist. Because the limit do not agree on the left and on the right. So Yeah. So in this case, we have the definition of the absolute values once again. Is equal to opposite if it is less than 0, and equal to itself if it is greater than 0. And then all we do is just divide by x. So we have -1 if x less than 0, and equal to 1 if x greater than or equal to 0. Actually, in this case, it's undefined at x equal to 0, so we don't really need the equal sign here. Okay, if we write like that, of course, the limit will be easier to see. Right, I did mention that divide by 0 is undefined. When we divide by 0, it is undefined. So what happens if we have 0 divided by 0? So what we have is 0 divided by something else. It's going to be 0 something else other than 0 divided by 0 is undefined. So when 0 divided by 0, what is that? Well, when we have 0 over 0, what we call is indeterminate. There will be more indeterminate forms, so this is only one of the indeterminate forms. So we have 0 over 0 is indeterminate. And as you say, what is indeterminate? Well, indeterminate meaning that it could be something else. It could be anything. Whatever method we use there does not work, we have to try something else. Right, so let's look at this example here. X squared minus 4 over x minus 2 when x equal to 2. Right, the first thing, put in the numbers, see what happened, right? So I'm going to put 2 in. Two squared is 4 minus 4 is 0 over 0. So this is indeterminate. That means it could be something else. We have to use different method. See, I do not write the equal sign because that could be something like this. So we're not going to, this is whatever we have here, it doesn't work. We have to try something else. Right, so what can we try in here? Right, and we'll say x minus 4, x squared minus 4, it can be factored, and that might help, right? So x squared minus 4 is going to be x minus 2 and x plus 2. It is factored that way. So here we have the x minus 2 and x minus 2 cancel out. And we only have x plus 2 left. Then I will substitute in the number again. And this time it is a well-defined number, so we make the limit equal to. Alright, and then some of you might think that I go a little bit fast here. How is that factor into this case, and how do we know? Well, actually, or when we have something more complicated, how do we factor? Well, in this particular case, factoring is a lot easier, right? Because we have one theorem in algebra, and that says if when x equal to c, the function is equal to 0. So when the function is equal to 0, when we substitute x equal to c, then x minus c is a factor. So because x minus 2, x equal to 2, when we substitute in, the top is 0, the bottom is 0, meaning the top have to have a factor of x minus 2, the bottom have to have a factor of x minus 2, so that's why it cancels out. Right, next, I substitute 1 in and see what happens. Just don't just jump into ahead and try to factor. Just put in numbers, see what happens. 1 square minus 4 times 1 plus 3. 1 square is 1 plus 3 minus 4, so that's 0. 0 divided by negative 1. 0 divided by anything other than 0 is 0, which is defined, so we just make it equal to. Right? So don't just go ahead and factor, even though if you can, it might not help. The most direct way is just put in the numbers, see what happens. If it is 0 over 0, that means both of them will have a common factor of something to cancel out. We see this, we see that on the next example. Right, put in negative 1, see what happens. Right, negative 1 square is 1, plus 4 is 5, minus 5, so the top is 0, the bottom is 0. Well, that is indeterminate. So that means we have to try something else. So in this case, we try to factor, because it looks like we can. Right, so how do we factor? So let's go back to the theorem that the note that we have earlier. If the function equal to 0 when x equal to a particular number, then x minus that number is a factor. So in this case, the common factor will be x minus that number, because we substitute the negative 1. So x minus negative 1 is the factor. Right? Which is minus negative 1 is plus 1. So let's see, there's something else here. Right, so once again, x minus negative 1, so we have a factor of x plus 1 and a factor of x plus 1. What is the other factor? Well, whatever we need x squared plus. So we have x squared plus 5x plus 4. We know one factor is going to be x plus 1. The other factor is whatever this is, we have x squared, so we need to have the x. So when we multiply now, we have x squared. We also need to have 4, so whatever we have here multiplied to it have to be 4. So when we multiply them out, x squared times that give us x squared, and 4 times 1 give us 4. Of course, the middle term, we have 4x plus 1x, which is 5x. So we only focus on when we multiply them out, we have to have x squared, we have to have 4, so then we have x and 4. Next, we need to have x squared, so we need an x here, and to have negative 1, 1 times negative 1 is negative 1. Right, common factor, simplify, just have x squared, x plus 4 over x minus 1. And we just substitute in a number. this time we have 3 over negative 2 or negative 3 over 2, and it is defined, so we make the limit equal to it. Right, so that helps a lot when we see there's a common factor, right? Right. Next, limit of this. Right, I put in a number first, as always. Four minus 4 is 0. Square 4 is 2. 2 minus 2 is 0. So this is also indeterminate. Now see, there should be a factor of x minus the limit, which is x minus 4. So we do have x minus 4 on the top. And saying, how do we get x minus 4 at the bottom? Well, so this is a special case. So remember, earlier we have x squared minus 4. We factor x minus 2 and x plus 2. Let me write out. A squared minus b squared is equal to a minus b, and a plus b. Right. So what? So how did that help? Well, it helped because the square root, if we want to undo the square root, a square of square root will cancel out. So we don't need a square. So in this case, it's just a problem that every time we have the square root, consider the what we call is the conjugate. So the a plus b and the a minus b is the conjugate. Conjugate. So it would be nice if we can get rid of that square root. So what we do is we use the conjugate of a term that has the square root, which is a plus. When we do that, we will have a square, which will take care of the square root, right? Right. Now if I multiply it out, by the way, you do not want to multiply the top because we do have 0. Remember, when we have 0, that means x minus that number is a factor. So we have the factor of x minus 4 already, which is good. Don't multiply what are not conjugate. Only multiply the conjugate terms, the conjugate expressions. Those are not conjugate. Don't multiply it. Just keep it as is. Now multiply them out. Square root of x times square root of x. Square of x squared. Square of x times 2. Square of x times 2. And 2 and 2. Right. The middle terms cancel out. That's the advantage of the conjugate. The middle term just cancel out. So we have x minus 4 and square root of x plus 2. At the bottom, that cancel out, just have x minus 4. As you see, when we have 0 over 0, when we have 0, that means x minus 4 is a factor. When we have 0, that means x minus 4 is a factor because we substitute in 4. That means x minus that number, x minus 4 is a factor. Indeed, we do have a factor of x minus 4 to cancel out. So we just have square root of x plus 2. And then we don't have the equal sign yet. I'll just put in 4 for x. And square 4 is 2 plus 2 is 4. And it is a defined number, so we make it equal to. Yeah, so when we have the square root, we try to get rid of that. And to get rid of the square root is multiply by the conjugate. Only multiply by the conjugate. If they are not, don't multiply them out. Right, so that's one way to do it. Of course, the conjugate is going from the right to the left. Now, if you don't want to do it, of course, there's another way. So I just say it alternatively. We can do it like this. We do have the square of the square root is equal to just x. So I will write as square root of x squared minus 2 squared. And here I'm just going to use a squared minus b squared identity, which is square of x minus 2 square of x plus 2. At the bottom, square of x minus 2. We can cancel this, and we still get the same thing. And then we substitute in form for x. And 2 and 2 is 4. Right? So either way. So when we have the square root, there's an identity. That the reason we use that identity because we need the square to cancel the square root. And multiply by the conjugate is usually the way to go. Right, different quotient. I'll end this section with this definition of different quotient. Different quotient of a function is defined to be that. So, find the limit of the different quotient of this. So first we find the different quotient. Let's write out the formula. Right, so that is a different quotient. So we have f of x plus h. Well, we have the function. So that means whatever we substitute in to x, we have to substitute in every x. So that's what a function does. So in this case, we have the function. So whatever we substitute here, we have to substitute there. Right? I'll replace all the x by a parentheses. Just leave it blank. Whatever we put in for x, we have to put in for every x. So replace both the x by the parentheses. Right. Then what we substitute in is x plus h. So when we do that, we have 2x and 2h plus 3. Right? F of x is the original function. So for this part, f of x plus h, say for this part, we're going to use 2x plus 2h plus 3. right? And then subtract. F of x is just a function. 2x plus 3. Make sure to subtract the whole function. Just put that in the parentheses. F of x just 2x plus 3. All of that over h. So I have 2x plus 2h plus 3, subtract 2x, distribute the minus, so that minus 3 over h. Well, we can simplify the 2x minus 2x, the plus 3 minus 3. So we just have 2h over 2 2h over h, sorry, cancel the h, we have 2. So we can say the limit of the different quotient when h, I forgot, for the limit of this, the prompt should be let's say at x, h go to 0. I put that in the note before I post note online, the handout online, that is. So the limit of this different quotient for this particular function is equal to 2. Why is that? Simply because we have the different quotient is equal to 2 and there's nothing to substitute in. So that's why it's equal to 2. So it doesn't matter what h is. I guess that's why I didn't write whatever the limit when h go to. So it doesn't matter what h go to. It's just 2 because the different quotient simplify to 2. So that's pretty much just the limit. Right. There will be a lot more example in this topic in the next section, but I just want to end this section here. See you in another video in business math. Thank you for watching.